Okay, so those are some of the techniques that might be used. Typical type of question you might get might show something, a setup, something like this. So here we have a pretty badly drawn plant, isn't it? But anyway, it will do. It shows the plant, and it shows here we've got a container. Now sometimes it's a flask, sometimes it's as simple as like a plastic bag that's been taped around the around a leaf. But the important thing is that container contains carbon dioxide, similar to this idea that we had earlier on, with a radioactive isotope. So I've chosen the isotope carbon-14 again. I think one of the questions in the question booklet uses carbon-13. The same principle applies, and that's absolutely fine. So this is question 8 in the question booklet, in the transporting plants question booklet, and it shows in the first diagram. It shows this setup, and we find that there is movement of those photosynthetic products to the top of the leaf, to the top of the stem, and to this sink at the top of the plant, where there was a measurement of the concentration as 3.24. I'm not sure if they give a unit there. It's an arbitrary unit for now. It also shows that there is movement down into the roots of 0.94. So there's evidence here. So we've got a sink at the at that growing leaf. And then the sink in the roots, where those carbohydrates may be stored. We've got evidence of movement from that leaf here to the top and to the bottom. Okay, then in the second diagram, this time that plant has been one of those. A second of those techniques has been applied. This has been ringed. Okay, so a ring of phloem has been removed from the from the stem, which should, as we discussed earlier on, prevent the movement of those photosynthetic products. And what we find is, at the top, 0.00. Okay, there have been no photosynthetic products containing that radioactive carbon-14 moving to the top. That confirms then that the removal of the phloem by that ringing process, or the ringing technique, prevents the movement up the plant. If we have a look down at the bottom, there is still movement into the roots. And there is also some movement of those photosynthetic products from the leaf up the plant, but below that ring of 0.34. So the photosynthetic products have started to move up the phloem towards the ring, but they're unable to cross beyond that ring. Okay. Next, in the next diagram then, it shows ringing below. This time, when there's ringing below, we end up with no products moving down to the sink in the roots. And in the final diagram there is ringing below and above, and there is nothing at the top, nothing at the bottom, and all of those photosynthetic products remain between the two ringed sections. Okay, so that confirms that it's the phloem, because only the phloem is removed by the ringing. Okay, I just want to check that, make sure I've got everything in. Yeah, I think that's everything. I also had a question somebody asked about question number 9 in the question booklet. So explain how radioactive substances reached position A and B. Right, so in question number 9, it's very similar diagram to this one, but without the ringing. Get rid of that, get rid of that, get rid of that there. So no ringing, but again, a radioactive isotope of carbon in carbon dioxide has been included, and it asks for an explanation of how radioactive substances reached position A and position B. Now, to answer that question, you may need to look back at the mass flow video that I made earlier on in the week, because it's basically a question about mass flow and the mass flow theory. So the only difference is that radioactive carbon is incorporated into the photosynthetic products, so into the carbohydrates, like sucrose, into amino acids, etc. That happens at the source, so this would be the source, and then the rest is a description of mass flow theory. So then the companion cells are involved in the active transport of sucrose from the source into the sieve tube elements of the phloem. That lowers the water potential of the phloem, so water moves from the xylem into the phloem, creating that high hydrostatic pressure at the source. There's a lower hydrostatic pressure at the sink, so those products in the phloem move from a high hydrostatic pressure at the source towards those lower hydrostatic pressures at the sinks. We've got A and B above and below, and that's because there is a sink in the root and a sink in the growing parts at the top of the plant. Right, I hope that was helpful. It's a tricky topic, but if you need to look back at the mass flow theory to get an understanding of how these things are, the processes that are actually taking place, applying that to these different techniques for measurement becomes a bit easier. Like I said, I hope that was helpful. Give me a shout if you need anything else explained, and I'll do my best to help you out. Alright, take care, bye bye.